In this video, you will learn how you can integrate a navigation system in your Compose Multiplatform app. Hi guys, my name is Yannick Reis, I hope you're doing well and I welcome you to a new video. When creating mobile apps, some building blocks are essential for almost any app. The one we want to talk about in this video is the proper navigation system. With system-bound native toolkits, we can access libraries like the Android X navigation library for Jetpack Compose on the Android side and the regular navigation view and navigation link components with SwiftUI for iOS. As of today, with Compose Multiplatform, an official direct navigation library is still missing. Fortunately, there are already some multi-platform compatible libraries out there that do an excellent job on this task, such as Decompose, Precompose, and Voyager. There's no right or wrong library to choose. However, in this video, we will focus on Voyager because I think it is a very good solution that is very easy to implement, allows type-safe navigation, and at the same time covers most of the use cases that you would want to implement in the course of developing a mobile app. The library is supported on Android, iOS, as well as desktop and web. It comes with a rich set of functionalities such as type-safe regular linear navigation and nested navigation with multiple backstacks. Additionally, the Voyager framework supports state management and integrations for various other frameworks like the coin dependency injection framework, which we will talk about in a later point in this video series. But enough of the talk, let's see how the library works in practice. We will cover linear navigation and how to pass arguments from one destination to another, tab navigation by implementing a classical bottom navigation bar, as well as nested navigation with multiple backstacks. If you're interested in those topics, stay tuned because we will get right into it. If you followed along my Compose Multiplatform introduction video, you should end up with this Compose Multiplatform template project. And here the first thing we need to do to use the Voyager library is to introduce some dependencies. So let's go into the shared module here and then in the build-graded KTS file. In that file, scroll down to the source set sections. And here, as you can see, we need to introduce three dependencies. One is the Voyager Navigator artifact, which contains most of the regular navigator stuff. Then we also have the tab navigator. And as you can see, we also include the transitions artifact, which is responsible for animations. Now that we have that in place, let's start with linear navigation. So navigation from screen A to screen B. For that, let's head back to the project overview here and we create a new class and call it screen A. And with Voyager, with each screen, we need to implement the screen interface. So let's do that. And if we go inside, you can see that we have an expected actual contract here. So we need to provide a content composable. So let's quickly implement members here. Then we need to add the composable annotation. And let's say for screen A, we want to have a text and also a button to navigate to screen B. So let's quickly do that by using a column. And now we can add a text composable that says screen A. And we also want to have a button. And here we can use the onClick parameter. And as you know it from Android Jetpack Compose, you can also add a button label here. So let's say navigate to screen B. Import. And now we can go back to the project overview and let's create screen B. So simply duplicate it here and then inside screen B, let's simply remove the button, adapt the text here to screen B, and we're done for that part. Next, let's go back to screen A. And now we can implement the onClick function here. So we want to navigate to screen B. With Voyager, we can access a so-called navigator. So let's say here, local navigator.current or throw. If in this local composition we have navigator, it will assign the variable here, otherwise it will throw an exception. So we need to make sure later that we also provide this navigator. Now I can simply call here navigator.push. And because we want to go to screen B, let's initialize screen B here. Okay, fine. Now we have set up our both screens, But how can we actually show them? For that, we need to go back to our app.kt file here. And if you haven't changed anything yet, let's just remove all the stuff here from the template project. And then we can also optimize the imports here. And now, as we already discussed, we need to provide a navigator. Let's say here navigator, which comes also from the Voyager library. And as an input parameter, we can say we want to have here screen A at first. So let's see how that looks in practice. The app is running, and as you can see, we have here screen A. When I now click on navigate to screen B appears. And if I use the back navigation, you can see we go back to screen A. Great, that worked. But something is missing, because if I click on the button, as you can see, the screen B just pops up. Where is the transition animation? For that, we use the Voyager transitions artifact, and Voyager provides some pre-built transition animations for us, like the slide transition. But of course, you can also implement your own transition animations. To use the slide transition, for example, let's go back to our navigator here, and now we can also here say navigator, and now let's simply call slide transition, input the navigator, and we can try it out. Back at our app, let's go to screen B, and as you can see, we have our slide transition. Okay, but what if I also want to wrap some other components around this transition here? For this case, let's say we want to have a top app bar, therefore let's say scaffold, and we introduce that top bar, top app bar, and now let's simply say text Voyager navigation import, and now we simply need to add the slide transition inside this content here, or as the content parameter. We can also use the inner padding here and add it as a modifier to the animation. So let's do that quickly. And if we rerun the build, you can see that the top bar is above the content here. Okay, nice, that also worked. But what if we have another common use case in which we want to pass an argument from screen A to screen B? That is also quite simple. We just need to go to screen B, for example, and let's quickly adapt this from class to data class. And let's say we have here a text arg. So a simple string, and let's also display it. So we say a text and implement or add the text arg here. And of course, now if we want to go to this screen, we also need to pass in that argument or parameter. So let's say here we come from screen A. Let's rerun. And if I now once again click on the button, you can see that here's now we come from screen A. And that is how you can pass in a type-safe way arguments to your next screen. Great, we now have a linear navigation. We saw we can use arguments and also wrap all the stuff in some outer layout. But what if we want to implement a common bottom navigation? For this part, we can use the tabs artifact. So let's say we have a tab A and a tab B we want to display. For that, let's head back here to the project overview, and we create a new object in this case. And let's say tab A, because we only want to have one single instance. And this time we don't implement the screen interface, but the tab interface, which on the other hand also implements the screen interface. And if we go inside, as we already used it from Android development, many deprecations, but we also see that we need to provide not only the content from the screen interface, but also options variable or tab options here. So let's go back and implement those two things. Once again, we need to add the composable annotation here above the get. And let's say for this content here, we simply use a box and say tab A, so we know where we are. And now we come to the interesting part, because the tab options here is essentially the metadata about this tab. So we have an icon, we have a title, and we also have an index we need to provide for this tab options here. So let's do that. Can say icon, and then we use a simple material icon. Let's say we use the home icon. Then we have a title, which is in this case tab A. And we can also use an index, which needs to be a ushort. So for the first tab A, we say here 0u. And then we can initialize tab options instance and simply provide all those three variables. Let's go back to the project overview. And here we simply duplicate tab A with tab B. Let's adapt that real quick to tab B. And we also want to adapt the index to 1. And also let's replace the home icon here with a settings icon, for example. Okay, now we have set up our tabs, but once again, we also want to display them. So let's go back to the app.kt file. So let's start by removing the top bar and replacing it with a bottom bar. And here we use the bottom navigation from material library. And as you can see, we have here a row scope inside. And we can now use a simple helper extension function on that row scope to help us to initialize the tab items. So let's say on the row scope, we want to have a tab item. And as an input parameter, we use the tab interface. And then what we need is once again a navigator, but this time the tab navigator. So we say here tab navigator, and we can receive it in the same way. So local tab navigator current. And now here we can access the bottom navigation item, as you might already know it from Android development. And now we want to implement the first variable, which is when is the tab selected. In this case, if the tab navigator dot current, so the current visible tab, is equal to the tab which we put into the tab item composable. The next thing is an on-click function we need to provide, because when we click on a tab, we want to display it, of course. So let's say here on click, and then we can access the tab navigator, say current equals to tab. And as the last part, we also need to provide an icon. So let's say here icon, and we can now access the metadata we earlier provided inside the tab declaration. So we say here options, icon, and as you can see it's nullable, so we use a let and say here painter. So if it's available, we can show an icon, and then we use the regular icon composable. We also need to provide a content description, and here we can also access the tab options. So we can use the title here for the description. So now let's head back to the top, and we can now simply use this extension function because we are inside the row scope. Say tab item, and first we use the tab A, and then also tab B. Now here's still the navigator provided. We need to, of course, replace it with the tab navigator. And also here we introduce the tab A as an import. Can remove the navigator from here. And here instead of the slide transition, we say current tab. So the current tab gets shown. Okay, let's rerun. And here we have now our bottom navigation. So let's click on the settings icon here. And as you can see, the tab switches from A to B. Okay, now we saw how we can implement the tab navigation. But what if we have some deeper navigation inside of those tabs? So each of those tabs also has an independent backstack. That means if I'm on tab A and I go a little bit deeper inside this hierarchy and I go to tab B, switch back to tab A, I'm still on that same screen. With Voyager, that's quite easy because here we can use our linear navigation example and only need to provide a custom navigator for each of those tabs. In this case, let's simply introduce a navigator to tab B. So go back to tab B, and here instead of the box, let's say we provide a navigator, and here we have once again the screen A as input. And for showcase purpose, let's also use the slide transition once again. And now back in the app, let's go to the settings tab, so tab B, and you can see we have here our linear navigation example. I click on the button and we go to screen B. And I can also navigate back here. And if I now go to screen B and switch to tab A, go back to tab B, you can see we're still on screen B. And with that, I think we covered most simple use cases you will face when implementing an app with Compose Multiplatform. However, there are some more functionalities. One is the multi-module navigation, which is also possible, and of course the screen model, but that is a part for another video. So as always, I hope you had some takeaways. Like the video, subscribe to my YouTube channel, activate the notification bell, and I hope to see you soon.